Hello, my name is Taylor Orzo, and this is my video lab report for NMR spectroscopy. So first, I'm going to go over the methods of how to obtain an NMR spectrum. So first, you will dilute your sample in an NMR tube. So this will include tetramethylcycline, and then equal amounts of chloroform D and your sample, and then shake the tube to mix. Next, you will place a collar on the tube so the thick end is by the cap of the tube. Push the tube into the NMR machine and then take it out and wipe it with a chem wipe to make sure it's clean. Then you will want to make sure the sample is spinning. And then to acquire the spectrum, you will go to the program pNMR. Then you will go to the program NUTS and hit A2. And then select DP to label the peaks for integrations and ID. So the purpose of this lab was to identify which of these elements is shown on this spectrum. So as you can see, it's pretty clear there is only one type of hydrogen here because we only have one peak, and the spin-spin splitting shows that it is a singlet, and it is at 1.412, and there like I said, there's only one type of hydrogen. So when I look at the spectroscopy sheet here, we can see at let me focus here, 0.9 to 1.4, which is where we are, ppm, is saturated CH far from other functional groups, as shown here. So when I look at the elements I can choose from, very clearly we don't have these because they would be down here on the spectrum. And also I want to note that since this is so upfield, it is more shielded. The nucleus is more shielded. So again, looking at these, considering there's only one type of hydrogen, it makes it pretty obvious that this is cyclohexane, and I can show that here by drawing it out. And if I draw out the hydrogens, you can see that they are all next to the same kind of hydrogen. So that is why I believe that this NMR spectroscopy sheet is interpreting that this sample that is unknown is cyclohexane.